welcome back to another video. So in this video we are going to discuss about the cloud on ramp. So as you know that the cloud applications are nowadays are in demand, and most of them are creating their application on the cloud itself to save the cost. Now if you can see that in the recent years, not only has the industry seen application migrating to the cloud on a massive scale, but born in the cloud itself also, and is becoming the de facto standard for application development, because the cloud is providing the platform for the application development in such a way that they are able to test their code, find the errors, rectify the errors, and deploy it automatically to the production. So it's a DevOps which has been in very much in demand. Like they will create the code that will be automatically testing it, do the push it to the development, their development. What do we say? VM, and after that it will push to the production VM. At the same time, the rapid adoption of business critical cloud services by nearly all organizations across every vertical is fueling all the things cloud and unveiling new challenges for network architects. So definitely it's challenges for us, because if we see the traditional way how things are connected, if it is in the cloud, so there will be a traditional firewall which will be connecting to the cloud using the VPN. So things become complex, the configuration will become a complex, and definitely for the network architecture, we need to design in such a way that it optimizes and we do have a good user experience. Now, challenges: providing reliable, flexible, and secure cloud connectivity models. So definitely we need to think about it. There are multitude of ways to each public or private cloud workloads, definitely because Azure works in a different way and the AWS works in a different way, and the security also is different. And application these days, network architects are now tasked to provide reliable and secure connectivity from branch, hub, or data center to these workloads on applications, ensuring optimal cloud application performance and visibility. Definitely, because if you see in a traditional way, things are connected via the VPN. VPNs means then we need to make sure that we do have enough bandwidth to um, host that one. Otherwise, if there is a oversubscription of the bandwidth, then the user experience will be not good. Since most networks have multiple egress points to the internet, it is important to ensure the best path. This is another challenge. If you have multiple circuits which is exiting on the multiple ISPs, then that's where another issue, because cloud is sitting on the internet, but you do have multiple exits. So that's what you need to plan also. And it is important to ensure that best path is utilized on a per application basis, and that performs the path is collected and available for reporting. So definitely whenever you have multiple circuits exiting via different ISPs, you need to make sure that it is being load balanced accordingly. If one of the ISP bandwidth or latency is being affected, it should automatically shift to other one. And plus you need to have some kind of monitoring system so that you get the visibility on that one. Designing scalable multi-cloud architecture. So this is where the designing issues comes in, because if you do have multi-cloud, that's again there is a complexity in the configuration. Organizations are starting to realize the benefit of multi-cloud environment when it comes to private and public cloud work placement. Ensuring that these architectures are scalable, easy to spin up and spin down, and stay cost effective is the key. So definitely the main reason for the businesses going to the cloud is that they no need to have a physical data centers or the physical asset on site in order to run the business. They can just rent out the space or the virtual machines or the cloud in order to run their own applications. Now, Cisco SD-wan Cloud on Ramp simplifies and enhances connectivity to software as a service applications by selecting the best performing network path based on the real-time performance. So if you remember that application aware routing which we have done the lab, where it will check for the SLAs, and using that SLAs it will automatically switch to between the business internet and the MPLS. So it's doing automatic routing for us like a policy-based routing. Now the same thing, the Cisco on cloud on ramp for the software as a service, it also works in the same way. It will check for the latency, it will calculate the loss, latency, and jitter, and accordingly it will make its own decision in order to forward the traffic for the cloud. If a path degrades, traffic is dynamically rerouted on a more optimal path. It also automates scalable multi-cloud connectivity to infrastructure as a service workloads by deploying virtual SD-WAN edge routers in a transit model. So we will discuss this one in more when we come to the infrastructure as a service, connecting the SD-WAN overlay to backend workloads. Additionally, cloud on-ramp for co-location supports secure and flexible service chaining architecture for application hosted in co-location facilities. So this is also one we are going to discuss later on in detail. Now, we will keep a focus on the software as a service only. With cloud on-ramp for software as a service, this SD-WAN fabric continuously measures the performance of a designated SaaS application, such as Microsoft Office 365, which is widely used through all available paths from a branch, including designated backhaul paths. So according to my diagram, I do have a data center one, I do have a branch one, and I do have a branch two. So currently, whenever they want to communicate with the internet, they go via the data center, then to the internet. So now with the cloud in place, I do have Office 365 in place. So what I can do is that I can deploy, I can connect, or I can just enable the software as a service on my SD-WAN, and I can define my application. After defining the application, it will automatically create one application aware routing policy, and it will automatically define its own SLS and start monitoring the paths. So one path is that it's going direct via the DC1, another path is going directly via the internet. Now the application aware routing policy will automatically calculate the loss jitter and the latency in this one, and it will make sure that which one is better, it will forward the traffic on that one. Okay, so because we created our policy and topology in such a way that traffic always goes via the data center one, since it is a lab, it will always take the data center one because there is not much loss or latency on that one. Alright, for each path, the fabric computes quality of experience score. So now for the each path, whatever might be the path in my topology, there are two paths. That is, one is going via the data center, one is going directly to the internet. Quality of experience scores ranging from 0 to 10, with 10 being the best performance. So it will give a score for the routes or the paths. If it is this one is 5 and this one is 8, so it will select this one. Now, the score gives network administrator visibility into the application performance that has never been available. So the fabric itself, SD-WAN fabric, is calculating things for you, and it is showing you, giving you the visibility what's going on with the different paths. So we will see later on how where we can see those details. Most importantly, the fabric automatically makes real-time decision. As I said that if the score is not good, it will automatically route the traffic to the better one. Choose the best performing path between the end user at a remote branch and the cloud software application. Enterprises have flexibility to deploy the capability in several ways according to their business needs and security requirements. So it's up to the enterprise, they can deploy it anyway. Now, the benefits of cloud on ramp for software as a service include the following: improve branch office user experience. So best we were looking or keeping the focus on the user experience since we started with the Cisco SD-WAN. For the software as a service application by using the best performing network path, increase SaaS application resilience with multiple network path selections and active monitoring. This is the main thing. Visibility into the software as a service application performance by using probes that measure real-time data. So it will send the probes. We will see soon how it's going to send the probes for the real-time data. Operational simplicity and consistency through central control and management of software as a service application policy. So it's operational simplicity and consistency. So that's what it is maintaining. So it's just a diagram over here how things will be working. You see that you do have Office 365 and you do have a Salesforce, you do have a SAP Concur. So it all depends where the traffic is coming in, how it is being calculated. So Manage will calculate all the optimization and everything for your applications. If it is Office 365 latency is good via this router, it will send it to this path. Salesforce, if it is better on this path, then it will send it to that particular path. So different path, it will select accordingly and it will forward the traffic accordingly. Now, Direct cloud access for remote sites allows software as a service application to be accessed directly from the internet. Again, as I said that I do have a topology of DC1, branch 1 and branch 2. Okay, so they always go via the data center 1 and they do also have an option to go directly to the internet. Whatever it might be the optimal, they will take it that one. Cisco SD-wan Cloud on ramp for software as a service ensure that only designated applications traffic uses this direct internet connection securely, while other internet bound traffic follows the usual path. For example, I said that I want to only check for the Office 365 that should be in the cloud on ramp for the software as a service. So Office 365, whenever the traffic is being matched, it will make sure that which is the optimal path. So if the direct internet is the optimal path, it will send it over here. Now let's talk about the Salesforce, which is not defined on the cloud. It will just send the traffic on a normal path because we don't have any policies for that one to steer the traffic. So that's why that application will be routed normally in the routing table. But the applications which we define in the cloud on ramp, that application, it will automatically create the application aware routing, and using that policy it will steer the traffic. This feature, known as direct internet access, reduces latency by avoiding the need of tunneling traffic to central site, thereby improving connectivity to prioritize software as a service application. Since I have defined the Office 365, so that is the priority one, so it will make sure that whatever the optimal path, it will keep on sending on using that path. Cisco SD-WAN Edge Router selects the optimal internet path for each application with different application potentially using different path based on the performance. Again, if I define the Salesforce, for example, for branch 1, the Office 365 direct connection is good, but the data center via the data center 1, the connection is not good. But for some reason, the Salesforce, the path is data center 1 via the data center 1 is good, but not good via the direct internet due to some issues maybe. So it will take that path because direct internet access there is a low latency and the path is good. So that's why it will prefer this path on the direct internet path for the Salesforce. So you can have multiple applications. It's not only Office 365 Salesforce. We will see later on what are the different applications which we can enable on that one. All right. So if any software as a service application becomes unreachable or its performance score falls below an unacceptable level, the path is removed as a candidate path option. For example, this score is 4 and this score is 8, so it will always take this one, but this path will be removed temporarily because it's not going to take it. Or if the path value is 0, so definitely it will not take that path. If all paths cannot be path candidate because of reachability or performance, then the traffic to the software as a service application follows the normal route. For example, now what happens is like from the branch 1 going to the Office 365 via the internet, both the paths are like 4 and 4 score. Both are not feasible for it. But in the routing table, we always say that go via the data center 1, so this will be selected. Alright, so whatever in the routing policy or the routing table, that path will be followed if both of them are in a worst score. The Cloud on Wrap for software as a service feature actively monitors software as a service performance and from each site over the multiple. So I do have a data center 1, I do have a branch 1, and I do have a branch 2. Once the cloud on ramp is enabled, so what happens is like for each and every site and device, it will keep on starting performing, collecting the data, and it will start calculating the loss jitter and everything and the performance. Now the WAN edge router views performance statistics differently depending on whether it is a part of DIA, gateway, or a client side. So DIA, direct internet access, so we already created branch 1, branch 2 as a direct internet access, while as the DC1 also the direct internet access. But for the branch 1 and branch 2, whenever they want to reach to the internet, we said that to go via the data center 1, so this one becomes the gateway in my case. Alright, so we don't worry about the client side because that's with the customer side. So we are only worried about the DIA and the gateway. A DIA or a gateway site calculates performance statistics of the SaaS application directly, but a client side does not. Since we are the DIA and the gateway both are going to forward the traffic based on the performance and all those things, not the client side because that's a customer, it's a different story. We don't worry about it for now. But they are the devices which are going to forward the traffic, so that's where they are going to perform the statistics of for the cloud on-ramp for software as service. Software as a service performs from a client side depends upon the software application performance from a gateway side plus the performance on the path from the client side to that gateway side. So talking about the client, there is a customer over here which you are managing. Again, it depends in order to communicate with the 365. It all depends upon the gateway latency and performance. In the case of DIA or a gateway site, the WAN edge router issues number of HTTP requests. So Cloud on Ramp by default it will send a ping request for every 10 seconds. But whenever there is a DIA site and a gateway site, it will send a HTTP request for every 1 second. Alright, so over each available path to the application in order to check the performance. It will just that's the difference for the DIA and the gateway. If you define the DIA and the gateway sites, the HTTP request will be enabled and it will send the ping HTTP ping for every 1 second to make sure that the application is reachable and it will start calculating that performance path statistics. Now, over a 2 minute sliding window, it calculates the average loss and latency of each application. So you will see in this diagram. So let's finish up these slides first. For every 2 minutes, it will calculate the statistics for the loss, latency, and the jitter. And using this data, the WAN edge router calculates the quality of experience QoE score. To get this score, the WAN edge router accounts for a average loss latency. We manage then collects this data, keeps a record, expect average loss. So it will calculate the average loss and latency for that from that data for the application. If the actual measured loss and latency are less than the expected loss and latency, then quality of score will be given 10. Okay, so just understand if actual measured loss and latency loss are less than expected loss. So maybe if you remember that in the SLAs, by default there are some SLAs. So the uh, loss will be like 2%, jitter will be, latency will be like 200 milliseconds. So if they what do we say, the SD-wan fabric is collecting the data, and after collecting the data it found out that there is loss only 1% and the latency is only 4 milliseconds. That is way much better than the expected one, right? Because this one was default defined by the policy, but it is much better than that, so that's why it will give a score as number 10 to it. Alright, so if an actual loss and latency are more than expected, so in a reverse way, it will give the score as a 0. Let's understand by this diagram. Now, my device DC1, branch 1 and branch 2, Office 365. Now, as we said that the branch 1 and branch 2 will be a DIA site, that means HTTP ping will be sending to the Office 365 for every 1 second. So every 1 second there is a ping going on to the Office 365. And there is for every 10 seconds there is another ping going on for every 10 seconds. So we do have this one data, we do have this one data. Every second data is there, every 10 seconds data is there. So with these two subsets, so we do have a 10-second data and we do have four subsets of 30 seconds. So this 10-second, one bucket, and another 10-second, second bucket. Just give it like 1, 2, 3, and 4. That means altogether I do have 40 seconds over here. Okay, so four sets of 10-second ping will accounts to one bucket. Okay, so not 4, it should be 3. So every 3, that is 30 seconds. So 10-second pings, we are sending a ping for every 10 seconds. So we will take an average of 3, that is 30 seconds. All right. So every 30 seconds is count as a one bucket. So in this one bucket, there are pings which are sent every 10 seconds, and we do have three pings, 1, 2, and 3. Every ping has been sent in an interval of 10 seconds. So these three pings together known as one bucket, and we calculate as a four bucket. So this means one bucket is around 30 seconds, and we are calculating the average for four buckets, that is 120 seconds. That accounts to 2 minutes. Now in these 2 minutes, now it has a data for every 10 second, 1 second, and every 30 seconds of subset of buckets. It's time to now calculate the performance of the path. Now these are the formulas which will be used by the Cisco SD-WAN fabric. Automatically it will calculate it for you, don't have to worry about it. But in order to know how things will be calculated, these are the different formulas. Using the different formulas, it will calculate the values. But how the values can be get here? Every 1 second HTTP ping is being sent, every 10 seconds, and every 30 seconds it will become one subset, and into fourth subset will become 2 minutes time interval, and within the 2 minutes time interval it will now calculate the average loss and latency for that particular path, and it will assign a score for it. Alright, so Cisco SD-WAN deep packet inspection. So what happens is like branch 1 is trying to communicate with Office 365. So this is the LAN. The first time the packet will go via the data center, because that's what we said. The first packet will go via the data center, then to the Office 365. So Cisco SD-WAN, it will use the deep packet inspection. So it will collect that packets and it will analyze it, and once it detects that it is going to Office 365, it will act upon it, and it will make sure that if it is a direct DIA, if it is a DIA side, it will calculate the path on a DIA. If this path is good, then it will go via the direct internet path. If the path is much better than the data center, then it will take the same path. Again, it will do the performance calculation statistics, and it will assign the score. For example, this one will be like 2, not 2, this one will be like 9, and this one is 6, so that means it will prefer the better one. After a couple of packets, DPI identifies the application and stores its identity in a cache, so that the subsequent flow going to the destination are sent out to the optimal exit determined by the Q quality of experience score instead of normal route. Now DPI does not redirect the initial packet flow, because the redirection work would cause network address translation changes that would break TCP connection. So the reason for that one, it doesn't break the flow for the first time, because is that it will break the NAT translation. If there is any NAT translation, it will break it. If not, then it will not. But definitely there will be a NAT translation on your service side with the service provider. But when we are looking on to the SD-WAN fabric, so when we are sending the traffic via DC1, there is no NAT. But since the traffic will be exiting via gig 0/0 most of the time, on this one we have configured as a NAT. So if the traffic is been redirected, what happens is like since it is a TCP connection, again it has to go with the traffic will be the whatever the user is doing, that will be interrupted, and the traffic new TCP connection should be initiated. So that's the reason it will not redirect first time, but whenever it identifies the packet, it will just from the next time it will redirect the packets to the optimal path. Alright, so this one is just an example how it depicts like how it works. So first time the traffic will go via the normal path. Alright, the second time again it will calculate the, because deep inspection will collect the packets. After collecting the packet, it will identify that one. After identifying the application, it will now wait for the another flow. Once the next flow is initiated by the different user, it will now forward the traffic on the optimal path. Alright, to calculate the performance statistics for software as a service application, the WAN edge router resolve the application names into the IP address using the DNS in the VPN0. I might have not shown you the how to configure the DNS on the VPN0, but it is pretty much straightforward. but still I will show you because it's within the VPN interface. So if I go to the configuration templates, let's go to the feature templates and we will say VPN 0. And if I click on edit, and you see that there is a DNS option and I have given the primary and the secondary DNS. That's all it is. So it's a pretty straightforward. All right, if it sends DNS query through each local internet exit. If a host DNS query is for the cloud on-ramp application, the local direct internet access exit is the best path. The router acts as a proxy, forwarding the query to the DNS over the best performing DIA exit. Again, the router will do the NAT translation for the DNS also. If the best path is through a gateway, WAN edge router, through the query is forwarded to the gateway, which then forward it to the DNS. Instead of going directly via the branch 1 going directly to the internet, if the optimal path is the data center 1, then it will send the DNS query via the data center 1. DNS query for non-cloud ramp application are handled normally according to the routing table. As I said, whatever you define on the cloud on ramp, that only application, those applications, if you're trying to communicate, then only it will check for the optimal path. Otherwise, it will send it on a normal routing path. All right, this is the again high diagram or the topology depicts how the DNS will be forwarded. But again, as I already explained that one. So if the DIA site, if it is a DIA site, it will directly forward the DNS to the internet. If not, it will direct the DNS query via the data center one if this direct internet access path is not optimal. And this is the same thing. Alright, so prerequisite for this cloud on ramp, prerequisite for all sites, including the IA client or the gateway. WAN edge router needs to be in vManage mode. That is the first thing. Yes, definitely. If it is not in a vManage mode, then we are not able to manage anything from the vManage. Simply attach a template so that we already know, and a minimum OS WAN router. So if you are using the Cisco C Edge, it should be 16.3 or later. If you are using, Viptela, it should be 16.3. If you are using CH, CSR, maybe C8000V, then it should be 17.1.0 or later. But you should use the latest recommended maintenance release, the minimum iOS. Now, before configuring the cloud on ramp for the software as a service, a default route to the internet, as you know that we already configured this in the previous topologies, a default route towards the internet is already there, and there is also a NAT enable on that one, must be present in the service VPN. And also, if you remember the service VPN, we have done the direct internet access. If I go to the branch, and if I say that admin show IP routes VPN 10 on tab. So if you remember that when we are doing the internet DIA, we have in order to communicate with the internet, we have advertise a default prefix on the service VPN, which will be natted to the gig 0/0 interface. So that's the prefix you need to have in every service VPN in order to communicate with the internet, and that's what we did in the direct internet access lab. Initially, first packet flow from the additional routing packet, as we discussed before, that the packet inspection will be capturing the packet. First packets will be flowing via the routing table. Next packet, the next flow will be going via the optimal path. Network address translation, again, that should be enabled on the direct internet access. Default route towards the local exit on the VPN 0, we already do have, and the DNS service on the VPN 0, we already configured that one. So these are all the things we already configured while we are doing the direct internet access lab in order to make sure that we resolve the DNS names. Now the summary, how we are going to enable and what we are going to do. The first thing is that we are going to enable the software as a service globally. I will show you how to do it. Then we define our application. Then we define our DIS sites and the gateway sites and the client sites. It's pretty easy. Next, command to check applications. If you want to check any commands in order to check some kind of statistics, then these are the different commands which you can use. So I have already put it on the slides so that it will be easy for you to understand. So let's go ahead and do the software as a service lab. So I hope this was informative for you, and thank you.